I think I'm seeing the problem from like 10,000 feet. The last time you were here, we started taking off all the exterior components of the engine. So the intake manifold, all that system, the exhaust manifold. We've got the transmission off, the bell housing, the flywheel. So we have this mounted up now to an engine stand so we can do the work at a reasonable level. So the first thing that we want to get into here is the cylinder head. This is a bit of a scary monster if you've never been inside a cylinder head before. This is a pushrod style engine, so we have all these rods that push on a cam from down below, actuate these rockers to push the valves up and down, which will close and open the exhaust and intake ports. It's a very precisely set up system. It's all running on very particular gears to make sure everything happens at the exact right time. So there's a lot going on in this one big cast piece of metal. Before we dig into the rocker arms and all of the cylinder head components, let's get rid of this little wooden sled that we've been running on so we can isolate the engine. Before going much further, we do want to get these motor mounts out of the way. As you're looking at these, you might be wondering, how do you know when your motor mounts need replacing? And there's a couple ways to tell. One is if there is a gap of less than 5 millimeters between this top of the saddle and the underside of the mount here. And then the other way is just if they look like this, they need to be replaced. It's really that simple. These are toasted. The ones in the front do seem to be a little bit better than the ones in the rear. In the rear here, we have complete separation almost. The part is literally just rusted away. The bond to the rubber has failed. And I can probably take this one off. There we go. Entirely. So, done. Now when I was starting to look for options on these, the Yanmar part is about $400 per corner. So that's going to add up really fast. So other options I was looking out there, and I found something that might interest you. So in here, we have a solution to that problem. These are the Ellebogen engine mounts. These are made by a gentleman named Aitor Ellebogen out in Spain on the Bay of Biscay, if I'm not mistaken. And he's got a similar story to me. He's an engineer that left his job. He was doing vibration mounts for industrial equipment. So he really knows his stuff when it comes to isolating vibration. And he had a sailboat with a Yanmar, realized his mounts were shot, and when he went to purchase them, he's going through the exact same thing we're talking about here. So he decided to start a business making his own mounts. So these are shipped to the United States. You end up about $470 US currently. You get 4 for that price. And this one has a keychain with it. So factor that into your decision. But these are super solid mounts, really nice rubber. They have tons of contact area here between the rubber and the metal. It is a steel base plate, but it's been zinc plated and then coated with 2 coats of this polyurethane paint, so it's got a really good corrosion resistance. I think they have a 5-year warranty, I believe. They use these special Nordlock washers, which are great for fighting vibration. So these should hopefully last a long time, and then you get rid of those rusty old Yanmars. So that's what we'll be putting on the boat. Now I do want to mention, Aitor gave these to us as a gift. Help get this project back on the road, so that was really generous of him. I'll put a link down in the description below if you want to check out his website. But if you've got a Yanmar engine, he does also Volvos, maybe others as well. If you've got rusty, old, decrepit mounts, this might be a good way to go. Now that we know we don't need these anymore, let's get them removed. Well, that one was removable by hand. Must be because it was below the fuel pump, probably getting leaked on for the last several years. Hi there, in case you're new here, my name is John and this boat is Antidote. I'm not a professional diesel mechanic. I am an engineer and a sailor with a dream of fixing up this old boat to go sailing around the world someday, but we've got a lot of work to do first. And lately we've been working on a bit of a side project here with this old Yanmar motor, trying to get it ready for a different boat. It started out as just a tune-up and it looks like it's going to get to be a pretty involved procedure here. If you're interested to know more about Antidote and the work we're doing on this boat, you can check out this playlist up here that'll take you to all of those videos. For now, let's get back to work on the old 27 horsepower Yanmar. We're going to start by pulling off those engine mount brackets. I knew there was a reason I was keeping all these old Bolt Depot bags. It's so I can relabel them, keep all these bolts organized. The time has now come to start breaking down this rocker arm assembly. The manual doesn't say that you need to back off the rocker adjustments before you take the arms off. I'm just going to do it anyways because it's going to take a little bit of the tension off the springs. We'll get everything loose and pull it off. I'm gonna have to redo all of the valve adjustments anyways, so it's really no harm for me. And these rocker arm assemblies actually all come out as one solid piece, which makes a lot of sense now that I look at the drawing a little closer. It's the following day now, and before we dive in closer on this, I had an idea. Actually, Jeff had an idea. If you don't recall, Jeff was in a few episodes ago. He helped us remove some teak wood from the cockpit in preparation for some permateak panels. It was a really fun video. If you haven't seen it yet, you should check it out. Put a link up here, but make sure you come on back. So Jeff has a Cape George 31 that he's done an amazing restoration job on with this same exact motor. Well, not this exact motor, a nice clean version of it. And he thought, hey, maybe John, you should come up and take a look at our boat. You can see if they sound the same or different. So we are gonna head up there right now and take a look. Okay, welcome aboard SV Narwhal. Jeff's gonna let us take a look here at their 3GM, and we're gonna see if that ticking noise exists. So I'm noticing that all of the engine has still got factory paint on it.
Yeah, I found it on Craigslist. The guy that had it had bought it for a project, and he had it for almost 30 years.
It looks like it's brand new, so it's pretty interesting to see because it's probably 20 years old at least, and looks fresh. Very cool. Wow, it's like a museum piece. Let's take a look. Okay, so I think I heard one right there. So that should be 240 degrees now. Yeah. So it seems to be clicking, but just ever so slightly. It's almost inaudible. There's a huge difference between what this one is doing and what ours is doing at home. So that's frustrating. All right, well, it looks like I've got more homework to do. I think we're gonna head back to the shop now, try and dig in a bit more and see if we can figure it out. But Jeff, thanks so much for your time.
No problem.
Appreciate it.
Yeah.
All right, well, back to the shop. While that is disappointing that it does confirm there is something wrong with this engine, it's at least nice to know that I'm not totally crazy. Well, I've spent some time here now barring this thing over a little bit back and forth because it's a lot quieter now that the valve train has been loosened off. So that is an interesting part of the problem, but it is still audible in there. So I've been using a mechanic stethoscope. It's just basically a little pin on the end, and you put this in your ears. You can really hear pinpointed issues. It's still pretty elusive though, trying to find this in here. I do hear it just ever so slightly right here. It just sounds like something's loose. So I think when we get into the timing cover, get this off, I think we're gonna find something interesting. A quick thank you now to some new friends of the channel, Fowler Precision. These guys saw what we were doing recently with some of the engine work and thought they could help out with some new measuring tools, micrometers, things like that. So very generous of you guys. Thank you so much. If you're interested, check out the link in the description down below. Now back to the video. Well, wouldn't you know it, I've found one more reason not to take the cylinder head off just yet. So you'll see here, I have the compression tester installed in cylinder number 1. Now I remembered that I have this old leak down tester that's been in the shop here and I've never used it. I got this from one of those cheap import tool stores. It's been sitting on the shelf for probably almost 2 decades and it's probably past its return window. Unfortunately, I don't know if it's working that well, but what it does do is it does let me inject air into the cylinder and I can listen around to hear if I'm getting leakage out of different points. So by rotating the crankshaft, because I have all the valve train disconnected, I don't have to worry about the valves dropping down and leaking, and I can kind of test the cylinder at all points. At least that's what I think I can do. So we're rotating the crankshaft and listening and finding out if the rings are sealing well. If they're leaking, you'll usually hear that through the crankcase, so maybe the oil dipstick tube, or in the case here, I have all these open chambers across the top for the push rods. And then if you are leaking past one of the valves, you'll hear that out of the corresponding valve port, probably the intake side or the exhaust side. If they're leaking from one port into the other, you might hear it in the neighboring cylinder, or you might hear things like through the head gasket. So you're kind of wanting to make sure that everything stays in your one cylinder, and that if anything, there's just a little bit of light leakage through into the crankcase, because the pistons are always going to let a little bit of air past because they have those gaps in the rings. What I'm finding is that when I run this pressure up above, say, 20 or 30 psi, the gauge this one just sort of saturates. This I'm just sort of ignoring, but what I am doing is I'm putting air into the cylinder and listening. And so I found a couple of interesting things on cylinder 1, and I'll show you here what I found. So while I'm doing this, I want to make sure I'm holding the crank still so I don't get things spinning around like crazy. And I believe that this thing's all the way at the bottom. Bit of air here. So that's like 20 PSI, close to, and I'm hearing a little bit of air now coming through. And I believe it's coming from the crankcase. Throw on our little stethoscope here. Nothing there. Maybe just a faint amount coming out of the exhaust port. But it's loud on the oil dipstick tube. You can go even further by then rotating this along the stroke. You might be able to hear some differences as you rotate. And right there it flips from top dead center. You can actually feel the crankshaft spin there as it goes down to the bottom. And there's the bottom. So I think what we might find here is that piston 1 has a bit of scoring in the bore. Potentially it's leaking a little bit past the rings, although some is always expected. But we do seem to hear an exhaust leak through the valve. So I think when we take the head off, the exhaust valve on 1 is going to need to be addressed. So I'm going to go through the rest of them, write all these results down before we take the head off. The results are in, and all 3 cylinders do have some leakage past the rings, which you would expect to find coming out of the oil dipstick, and that's normal to some extent, but they don't seem excessive, any of them. As I turn the crankshaft in the compression stroke direction, I do see the pressure increasing on the gauge, which tells me that, it's working. And then when we get to top dead center, I do hear an audible increase in the amount of leakage past the rings. So that could indicate that up at the very top where the combustion is occurring, that there is more chatter, or there could be a bit of a wear pattern there. So there you go. So it's not really an official leak down test, but it does give you some idea about the condition of the cylinders and the valve train before we tear anything apart. Of course, once we pull the cylinder head off, we can't do that anymore, and we've compromised the seal of the head gasket. So that was the right time to do it, and I think that's pretty interesting, even if that wasn't a completely accurate leak down test. And if you're finding this part of the video interesting or helpful maybe for one of your future engine projects, it would mean a lot if you'd hit that like button for me. It really does help with the channel and getting this video out to see more people, so I appreciate it a lot. Thank you. Now, I think we are ready to pull off this cylinder head. Almost forgot to pull out all of the push rods. So I have a little tray here that I've marked off cylinder 1 to 3 and intake exhaust. So this way I can keep everything organized, and I know that I want to put these push rods in the same way that they came out. So I've marked the top and bottom of the cylinder head, and hopefully everything goes back in the way it's supposed to. That's the plan. Now, I might be telling you something you already know, but especially with a cylinder head, when you're taking the bolts out, you have to go really slowly and progressively. And there's a tightening sequence to these that's kind of in a crisscross pattern that the manual describes. And so when we start backing them off, we're going to go in the reverse order. Let's take a second to thank some of the new Patreon and YouTube members that help keep this channel floating along. Now, if you're interested in some extra updates and ad-free videos, you can check out the Patreon link below or hit that join button. Now, the folks whose names are appearing on the screen go the extra mile to keep this channel working, and I couldn't do it without you. Thank you all so much. Now, back to the video. We've got everything loosened off. There's no more bolts in there. Just the head gasket holding it on. So let's see how this goes. With the head off, first impressions, the underside of the head looks really good. There's a little bit of carbon buildup, but don't think there's too much. I don't see any rust indications or streaks that might indicate that water has been leaking from one chamber into another. So I think that looks pretty good. And then in the cylinders here, the walls look really pretty good as well. I still see quite a lot of cross hatching. There is a significant amount of carbon at the top where the rings don't get to. The tops of the pistons do have some obvious carbon deposits on them. Perhaps the most concerning thing is that I have an impression of the exhaust valve on the top of each piston. I don't know if that's because it's actually struck the piston, or if it's just that as the piston comes up, carbon can't form there because there is such tight tolerances. I know that these motors come up right to the top. There's essentially zero gap in there, and that's how they get that really high compression. So maybe that's normal. I have seen some pictures online of this sort of thing, but anything that might indicate the valve striking a piston is cause for concern. So I'm turning the crank and I'm seeing if any of the pistons looks like they don't come up as high as the others. They all look just about the same, and they all come up quite high. So I don't suspect that we've had a strike or a conrod bent. And when we pull the valves out, we'll see if they are all straight as well. But based on how leak-free the head was, I think it's probably going to be okay. So all of this is going to get validated by a proper machine shop in town here. They've done some motors for me in the past. So we'll take it to him, see what he thinks about the cylinder condition, and the head and whatnot, and maybe we're going to be okay to use some of these parts again. Still got to find out what that rattle is in there. I can hear it still, so I think next thing is the timing cover. Right there. You don't want to hear that sound. With the fuel pump off, I think I'm seeing the problem from like 10,000 feet. I don't know what has caused this or how to fix it yet, but I can actually turn the crank, I don't know, 5 degrees, 10 degrees, and it's not engaging the cam. So those should be always meshed, constantly turning at the same time, twice as fast for the crank as the camshaft. So the fact that that is not working is frightening. So next step is to remove the whole timing gear cover, and then hopefully we can take a look at what's actually going on in there. Crazy. With the timing cover removed, we do get a pretty good indication now of what's happening and why the crank gear is moving on the crankshaft. It looks like the keyway and the key itself are probably pretty munched up, and it's allowing 5 degrees, maybe plus or minus rotation. So that is no good. That means that the timing of this engine is essentially continuously variable. It's just it doesn't know what it's doing. So it's not variable in a good way. Wow. Now removing this, it looks like the keyways are the same, and I actually have confirmed that with the part numbers. But yeah, you can really see this keyway is munched up. A lot of force to do that. Let's put the good one from the pulley back in there and see if that reduces the play at all. Well, with the other key in place, the movement is reduced. It's still way more than you want. This needs to be a tight fit. So I think what we're gonna find is that the keyway inside the gear is probably a little bit damaged. The key obviously was, and in the shaft is critically the part that has probably suffered the most damage. And I can kind of see it just looking at it that it's been widened out. Now, we're gonna have to get that repaired if we wanna keep going with this engine. So that's a bummer. We'll contact some machine shops, see what the options are. Maybe there's a new crank out there. I have a feeling though that the crank itself is gonna be more expensive than what we paid for the engine, and that's just not gonna work. So, see what we can do. For now, we keep taking things apart. Well, we got the oil pump out. It's a bit tricky to pull that thing out. It's a very, very tight fit, but I guess that's what you want to make sure you pump the oil properly. Now, while I had the gears together here, I did check the backlash between the crank and cam gears using a piece of solder. So we just ran that between the gears, and as it crushed, we pulled the reading off. And so this might be a little on the high side. It says 0.24 millimeters. That's below spec, so on we go. So now I cannot get this nut free on the camshaft gear, and I have an impact that's coming, and I hopefully will be able to just crank that off. That's gonna get here tomorrow. So while we wait for that, let's drop the pan. Any last little bit of oil will come out, and then we'll start pulling these pistons out through the top. Now they always say to install piston rings with the gaps as far away from each other as possible, but they obviously don't stay that way because look, we're pulling this one out and they're all within 90 degrees of each other. Well, there you go. And that has the number 1 piston out of the bore, and it looks pretty good in there. The bearing shells in the conrod look good so far, so we have a few more that we need to check here before we're happy, but I did find a shear pin from that governor that had fallen off. It's stuck up inside the underside of piston number 2 here, so we'll get that out in a second. It's crazy to me that this thing didn't have it worse off. Let's get the other 2 pistons out, measure everything, make sure it all looks good. Keep tearing this thing apart. We're getting everything organized over on the bench so we know exactly how it goes back together. We don't want to put any of these parts in any different orientation. Everything wants to go exactly back the way it is. Well, this block is almost emptied out, so the next thing we want to do is remove the crank here, and that actually has to come out the back of the block, so this base plate's in the way. And this thing's still pretty hefty, and so thankfully I've got some help here today. My father is here, also named John, so that was very confusing as a child growing up. We want to pull this thing out together, so I think if we just grab it, we can lift it out and we'll set it down on the head, and then we'll be able to pull this out. The block is almost completely hollowed out here. We have the crank free, and now everything is looking pretty good. We did notice that there is some wear on some of the bearings for the crank and on the piston on the large end of the conrods as well. But we'll see if we can get all this tuned up. We've got some parts on the way. We're going to take all this to a machine shop here, hopefully tomorrow, to get them to kind of look over it, give us a second opinion. But everything that I've measured so far on the crank and on the piston seems to be in good spec. So I think we're going to be able to get this all back together. Now I've been waiting for this guy to arrive. It's a massive 30mm extension socket, so we can take off this cam gear. So we're going to get that going now. Let's just see how this goes. Well, that's a $20 socket that I'll probably use twice in my life, but it probably saved me several hours of working on this piece, so I'm happy to have it. If anyone needs a 30mm, 8-inch long socket in a couple of months when this is done, send me an email. As we're trying to pull the fuel cam off, it sort of seems like it's hitting a hard stop. It definitely moves, then it kind of clicks. I think maybe the keyway is just a little bit tight. So the only thing I can think to do to get that out is to hook up the slide hammer here. So we're going to try this now. Well, once again, the slide hammer for the win. This thing has come in handy so many times. And it looks like the cam is in good shape, no markings on it, and we did try to protect it a bit. So on we go.
Beautiful.
And with that, the block is emptied of all of its components and it's ready to head out to the machine shop. So I think this is the perfect time to ask you to hit that like button for me. Appreciate that so much. So truthfully, it's not completely ready for the machine shop yet. I have a couple of plugs here that were on the back that I hadn't investigated yet. So as soon as I removed those, I found out that they were actually old zincs. and they are completely decrepit and decayed. So we'll need to get these replaced as well, and we'll do that as we refresh the motor. So we've been measuring all of the pistons and all the external components with the micrometers, getting all those measurements written down, comparing them to the specs that are in the Yanmar repair manual, so I know that everything is still in its maintenance window. Then I've also been having some fun with the bore gauge, playing around in here, getting all these internal measurements taken, and this has been a really awesome tool for verifying that all the clearances are correct. Now the machine shop is they will definitely go over these again, make sure that they agree with the numbers and that everything is within spec and that they believe the engine will go back together in a good sense. I'm hoping that it will. I think the pistons are going to be okay to go again, although I did confirm that, and this is probably the best of them, that they have all struck a valve at some point. But this one here, you can see there's a full imprint. That's the intake valve. Good smack there. So I'm surprised this thing still runs at all. I think the motor is okay, even though there has been some interference, even just the slightest bit. Very crazy. But we'll have all that double checked. Now we're getting ready to send this crankshaft off to our friend Gary in Texas, who's going to take a look at that keyway. And I thought I would show you something interesting. This is the original gear, and remember that it still moves quite a lot, even with the good key from the forward part. Now I was able to find a new gear online from a tractor supply store. So we're going to throw this on here, and I've noticed that even though the keyway in the original gear looks pretty good, it looks like it might be okay, this new part, even without any machining from Gary, has a really nice fit and almost no movement, a lot less, probably less than half the movement. So I'm pretty confident with a little bit of work here on the keyway, we're going to be able to get this back in good order. I'll box these parts up in a minute for the shop, but let's take a look at that head really quick. I want to take at least one of the cylinders apart just to see what's inside. At first, the retainers for the springs did not want to pop out, and I almost gave up because my compressor tool was not quite getting the job done. But I decided to come back with a bigger clamp, and I was able to pop all of those free. And then after that, it was a quick disassembly to remove each of them. So we've kept all of them, of course, in their individual compartments so we know where everything is going to go back again. We measured these valve stems up. Some of them are a little on the smaller side compared to what the spec should be. So we're going to be interested to see what the machine shop thinks of that. Maybe we need new valve guides, but I'm not sure. Possibly new valves as well. The valve stem seals pulled off pretty easily, and they seem to look okay. It's hard to tell because they are pretty small. Probably need like magnifying glass to really know for sure, but these are going to get replaced anyways. So we've got all of the combustion chambers pressed out of the head. So all that's left in there now is these copper washers, which I cannot get out very easily. So hopefully the machine shop can help with that. And then on the other side, the seats look to be, I don't know, I'm not an expert here. Some of them look okay, others look kind of burned. Again, we'll have these evaluated by a definite professional, and we'll check back in. So there's only one thing left now that isn't completely broken down on this engine. That's the heat exchanger. So we can't, of course, leave that stone unturned. Let's get to that next. So the last thing we want to disassemble here and check out is the heat exchanger. So this exchanges the freshwater loop of the engine with seawater that is pumped up from underneath the boat, and this helps keep the engine running at the proper temperature. And now you want to make sure that there's obviously no leaks here, but that also that you're not mixing the fresh water coolant from the engine with the seawater. And then the exhaust from the motor also comes out the side of this and gets pumped out the back here, so it kind of keeps the whole thing cool. Now, before we tear this all the way down, the manual does specify a pressure check where you can pump it up with some air to make sure that there's no leaks. So why don't we do that really quick before we move ahead? Know that we have a good part here. So we're just going to cap all these holes up. I found these rubber legs from the hardware store, and these actually fit pretty well over these caps, so we'll try and bind those up and make sure that we can pass air through here. Then to close off the raw water loop, I have cut off some spare lengths of rubber coolant hose here, and we are going to clamp these down on one side with traditional hose clamps, and then on the other I have these pinch-off clamps that are really great for taking care of these open ends. So this should be ready for a swim now, and we're going to hook this up to the air compressor. So let's start at the low end of the test spec, which is 10 psi. Go up from there. Well, immediately we have two leaks here. We have one out of the coolant overflow, and it's pretty aggressive. And then we have a very, very small leak coming out of the outlet for the fresh loop. So we'll see if we can tighten these up and get rid of those. It looks like we were able to tighten up the one on the overflow tube, and everything else seems to be holding, except we do have two very small leaks still on the freshwater side. But these appear to be coming out from underneath the rubber boot and not actually anywhere in between the seals. So these are pretty corroded parts. I've actually already got these on my list to order new replacement parts for these because they are original. And they look pretty rough, so I don't imagine they're going to seal too well. And this type of rubber on this little boot is not the kind of rubber you'd get on a coolant hose, so it's not as pliable, so it probably doesn't seal as well. Let's call this a pass and open up one side for the raw water loop, and that way if there is any holes between the tubes in the heat exchanger core inside here, those should start coming out as bubbles now. Let's see. That little shot of air is probably just a pocket from when we put this in the tank. We also ran the pressure up to about 25 psi, which is near the top end of what the manual suggests. No appreciable difference. So to me, this all looks really good. We don't have any air coming through either side of the system. They're not cross-contaminating. This looks good. Let's get this out of the tank and take it apart. And that is the last of it. So everything now is hollowed out, ready to go to the machine shop. We'll have them hot dip these parts, clean them up for us, measure everything, make sure everything's gonna go back together. Nice spick and span. Well, I'm so happy to have finally figured out what was causing that bizarre engine noise. Now I'm very interested to see what the machine shop thinks about all of these parts when we drop them off. In the next video, we'll take a look at the work that they want to do, and we're also going to probably start pulling into some of these other components, like maybe that transmission that's laying over there. Then we're going to start cleaning, repairing, replacing, and rebuilding this old Yanmar motor. So I hope you're finding this little side series interesting. If you'd like to go to the beginning of the engine series, you can check out this playlist down here. If you want to know more about the rebuilding of Antidote and what we're doing on that boat, the playlist starts up here, and you can hit that button to subscribe for more. And hey, let me know in the comments where you're watching from, okay? See you next time. I might be able to completely separate this on my own. Maybe if I went to the gym a little bit more.
Ready to go?
Yes. Okay, but we're not.